Hey math kids, today we're going to talk about increasing and decreasing, and the general idea is remembering that derivative talks about slope, and so these points are where we change from increasing to decreasing, and so let's say that they are at these points. Okay. And the first question just wants us to state the intervals where we're increasing and decreasing. So increasing, we have two intervals. So it's either when x is less than or equal to -1, so meaning this portion, or when x is greater than or equal to 2, so this portion. And then decreasing is in between those two x values. So it's -1 is less than or equal to x is less than or equal to 2. Now something that's kind of weird about how IB does this is they insist on having the less than or equal to. And so what that implies is right at -1 and right at 2, it's both increasing and decreasing, which to me feels a little counterintuitive, but that's how IB wants you to do it, so that's how you need to do it. I would argue that it's not increasing or decreasing at those points, and I would not use the equal to signs under here if I had a choice. Okay. Now, next one, find the intervals where the following functions are increasing or decreasing. Okay, so what we have to do for this, we have to keep in mind that the derivative at those points where it changes from increasing to decreasing is equal to 0, because the slope of a horizontal line, so if we had something like this, the tangent at that point is going to be horizontal, which means the slope is going to be 0, and so that's kind of the thinking behind this. So f prime of x is going to be -3x squared plus 6x. And then if we factor out a 3, let's do -3x. That's going to leave us with x minus 2. And then we're going to set that equal to 0 because we want our derivative to equal 0. We can break that apart and we get 0 equals -3x. 0 equals x minus 2. So x equals 0 right here, and x equals 2 right here. So on our sine diagram, we're going to have 0 and 2. I'm going to choose -1, 1, and 3. I'm going to look right here. If I plug in a -1 right here, that gives me a positive answer. If I plug in -1 here, negative. Positive times negative is negative. If I plug in a 1, I'm going to get a negative. Plug in a 1, I'll also get a negative. Negative times negative is positive. Plug in a 3, get a negative. Plug in a 3, get a positive. Multiply those together, we get a negative. And so we are increasing when we're in between 0 and 2 because of the plus sign. And then we're decreasing when x is less than or equal to 0 and when x is greater than or equal to 2. Okay, over here we'll do something similar. So our derivative is going to be 12x cubed minus 24x squared. We're going to factor out a 12x squared. That leaves us with x minus 2. And if I set this equal to 0, we can break them apart. So we add 2, x is equal to 2. Divide by 12, square root. We end up with 0 is equal to x. Okay, so our axes are actually the same on this one, 0, 2, so I'm going to choose the same values, -1, 1, and 3 to plug in to, no, let's do it here. Okay, no matter what I plug in here, it's going to be a positive, so I can actually ignore that, because positive times negative will just stay negative, positive times positive will stay positive, so really we just need to focus on this. Plug in a negative here, that's going to be negative. Plug in a 1, that's also going to be negative. And plug in a 3 right here, that's going to be positive. So, increasing is going to be when x is greater than or equal to 2. And decreasing is when x is less than or equal to 2. Okay, we have f of x is equal to 2x minus 3, x squared plus 2x minus 3. So the first thing is we need to find the derivative and draw its sine diagram. So we're going to use the quotient rule. So if I call this u and I call this v, u prime is going to be 2 and v prime is going to be 2x plus 2. And if I do the quotient rule, I'm going to end up with this. Okay. Now, we're trying to show on this, they give us the derivative, and we're trying to prove that it's that. Okay, so this green one is what we're shooting for. The blue one is what we're using to show that. And so, what we need to do, the bottom, we can just t-factor 1 and 3. We'll make the 3 positive and the 1 negative. And so that's going to be x minus 1 times x plus 3 quantity squared, and then we can distribute the squared to both. So we've shown that the bottom is the same. Now we just need to make the top look like the top over here. And so what we're going to do, we're going to distribute right here. So I'm going to get 2x squared plus 4x minus 6. And then distribute over here. We're going to get 4x squared plus 4x minus 6x minus 6. Combine these to negative 2x. Distribute a negative to all of these. Negative 4x squared plus 2x plus 6. And if we combine these, we get negative 2x squared. If we combine these, we get 6x, and then these two cancel. We can factor out a negative 2x. When we do that, we're left with x minus 3. So we just proved that the top is the same. Alright, now the next thing is it wants us to find the intervals where f of x is increasing or decreasing. Oh, actually we needed a sine diagram. So we can set this derivative equal to 0, and it's going to leave us with x equals 0 and x equals 3. So our sine diagram is 0 and 3. And if we plug in negative 1, 1, and 4, if we plug in a negative 1 to this, oh, we also need to do asymptotes. So we have positive 1 and negative 3. So positive 1 and negative 3. So negative 1, 1/2, 4, 2, negative 4. Now, if you plug in a negative 4, it's going to give us a negative. If we plug in a negative 1 to this, it's going to be a negative number. If we plug in 1/2 to this, we're going to get a positive number. And if we plug in 2, we're going to get a positive. If we plug in a 4, we're going to get a negative. So that's our sine diagram. Now, for increasing, we're just going to look at all the areas where we're positive. So we're going to go from 0 to 1, and because it's like an asymptote, it's going to kind of look like that. Possibly, something like that. Wait. It's not going to look like that. It's going to be more like that. It's going up, going up. Okay. So we're going to be increasing, and then we'll kind of take a break and then go increasing. So when it's increasing, we're going to say it's in between 0 and 1, but this time with an asymptote we don't do an equal to, and then we're going to say in between 1, once again, no equal to, and then 3. Okay, that takes care of those. And then for the negative, for the decreasing, we're going to do a similar thing right here, because we're like going down and then down like that. We take a break at negative 3, so we're going to say x is less than 3. We're also going to say 3 is less than x is less than or equal to 0. And then right here is going to give us x is greater than or equal to 3. If you need additional help, please come to Math Lab. Until then, calculator.